Welcome everybody to a new video of calculus. In this video, what we're going to learn is limit at infinity. Okay, so this video, the title says pretty much everything we need to learn. So before I get started, the reason why we're reviewing this one is because limit at infinity can help us find horizontal asymptote, and this is very useful for graphing, and this is why you have to learn this. So I'm just gonna give you a quick example. Limit. Let's do limit as x approach infinity for x. Well, it's gonna give us plus infinity, right? But if I put limit as x approach infinity, but at minus x is gonna give us minus infinity. So that's a basic concept you guys need to know about. There's minus infinity and plus infinity. You just need to know when it's minus infinity or plus infinity. Alright, so now that you guys are more familiar with this, let's give you guys another example. Okay. Oops. So this time I'm gonna do limit as limit as x approach infinity, and this time it's gonna be 1 over x. You guys can take a guess what this is going to get. What is my answer right here? But I'm just gonna say it right here. My answer is gonna be 0. Okay, that's right. Anything over infinity is equal to 0, and you guys can put a test for it. You guys can put 0.0001. It's good. Let's take your calculator, and you see it will give you a big number. So in my case, I got 10,000. Right. So that's why the smaller my denominator, the bigger my answer. And this is why where my x is approaching infinity in my denominator, my limit is also approaching 0. Okay. So this is a basic what you need to know for limiters at infinity, because we're going to be using 1 over x to evaluate other complex limits, and this is certainly very helpful. So let's give you guys an example right here. So let's take limit as x approach minus infinity, and we'll do 1 plus 4 x to the power of 2 minus x to the power of 3. Let's evaluate this limit. Okay. So the first thing if I notice is that if I put, actually, let me change one thing, because before I do this, I don't want to complicate your life first. I'm just gonna do infinity because that's easier. You're gonna see later on if I put minus infinity, that's gonna be a different thing. So the first thing I'm starting with infinity. Alright, so let's start this. Limit x approach infinity. Normally what we do is try to simplify, conjugate, or factorize. But here we can't simplify, we can't factorize, and we can't conjugate. What we can do though is divide everything by x. Divide everything by x that has a greater power right here. So this x has is power to the x to the power 3. So I'm gonna divide everything by x to the power 3. So let's do this. So here I'm gonna multiply by 1 over x to the power 3. This is a big parenthesis. And the same thing in my numerator. Alright, multiplied by 1 over x to the power 3. So it's always a greater power that's going to be multiplied with 1 over x to the greater power. So yeah, we'll do as a couple example for you guys to be more used to this, but right now let's continue with this. So what we're gonna do, we are gonna start with the denominator as it's easiest to simplify. So what we're gonna get is 2 over x to the power of 3 minus x to the power of 3. Okay, and in my numerator, I want to plug in my x to the power of 3 in my root. So just gonna put a simple fact right here. X to the power of 6 square root of that give me x to the power of 3, right? Because x to the power of 3 times x to the power of 3 give me x to the power of 6. I hope it's not too confusing for you guys. Alright, so that's how we're gonna do. We're gonna do square root of we're gonna make that square root of x to the power of 6, because square root of x to the power of 6 is the same thing as x to the power of 3. So here we're going to do 1 plus 4x to the power of 2 divided by x to the power of 6. Let's just distribute it right here. Okay, so that's how you plug in your x. I'll just make my square root a bit bigger. Alright, so let's see what can we do. I can divide x to the power of 2 divided by x to the power of 6. This is going to cancel out, give me 1, and this is going to give me 4. Okay, so here in my denominator, x to the power 3 divided by x to the power 3 give me 1. Alright, now let's continue this. We're gonna get x approaching infinity. 1 over x to the power of 6 plus 4 divided by x to the power of 4 divided by 2x 2 divided by x to the power of 3 minus 1. So let's plug in infinity. Remember when I said 1 over infinity give us 0? Well, here's it apply in my limits. So 1 over infinity, 1 over x to the power of 6. If I plug infinity, it's going to give me 1 over infinity. So this is going to be 0, remember, because of this. And 4 over infinity also give me 0. And 2 over infinity also give me 0. Okay, so my final answer is going to be 0 over minus 1, which will give me ultimately 0. So this is how I deal with limits, with infinity. Right, so let's do another question. Right, so the first question I'm gonna ask is also x approaching limit, x approaching infinity. Okay, so here I'm gonna write also square root. Oops, let's put this a straight line. Voila. So x to the power of 3 plus 1 square root of 2 x to the power of 3 plus 6 to the power of 6 minus 1. So let's do this one. So what I must do first is try to see what is my highest power in my denominator. And I found out x to the power of 3 is my highest power. So what I should do is divide it by x to the power of 3 everywhere. So x to the power of 3 divided by x to the power of 3 plus 1 divided by x to the power of 3. Now I want to put my x to the power of 3 in my square root. So I'm going to do 2x divided by 2x to the power of 3 divided by x to the power of 6 plus 6x to the power of, let's just put it up, 6x to the power of 6 divided by x to the power of 6 minus 1 divided by x to the power of 6. Alright, so let's simplify this. This is gonna give me 1. This is gonna cancel out. This is gonna give me 3. This is gonna give me 1 here. Alright, so let's write it again. Right, so this is gonna give me 2 divided by x to the power 3 plus 6 minus 1 over 1 over x to the power of 6. Let's write it more carefully. Alright, so now my denominator is gonna be 1 plus x to the power of 3. Alright, now let's plug in infinity. So here I'm gonna get 0. This is gonna be 0. This is gonna be 0. It's gonna be 0. Because remember again, 1 over infinity or anything except infinity over infinity. So I can have like a 3, 2. It's always gonna give me 0. Anything over infinity is gonna be 0. Except for infinity over infinity. Remember, infinity over infinity is undefined. Alright? So if you reach to this conclusion, you know you did something wrong. And you need to try again. The goal of finding limits is not to find undefined form. The goal of limits is to find a point, or is to find if the limit exists. So let's continue. This is going to give me 0 plus 6 minus 0 divided by 1 plus 0. So this is ultimately gonna give me square root of 6. Now, what I'm gonna do is take the same function right here. Let's just get more place. I'm gonna take the same function. Let's erase the top right here. Actually, let's erase this one because I want to compare my result. This time is going to be minus infinity, but the function stays the same. So if I remember, 2 times x to the power 3 plus 6 x to the power 6 minus 1. Yep. Divided by x to the power 3 plus 1. Alright. So this time it's the same as I always did. I divided everything by x to the power 3. Okay. And nothing changed in my denominator. However, I'm going to put a negative in front of my square root. Alright, and I'm going to divide everything by x to the power of 6. So the reason for that is, let's just take this example. It's going to give you plus or minus 1. Okay, and when there's a minus infinity, and my denominator is it can be negative or positive. For example, if I put minus 1, if I put minus 3, for example, plus 1, I'm going to get a negative number in my denominator. Okay. However, if I put a negative number in my square root, it's always going to return me a positive number. This is why I put a negative number in my denominator, right? So every time you got the square root or absolute, you're gonna get plus or minus 1, right? So if your denominator is if your denominator can return you a negative number, put a negative number in your numerator if it's square root or absolute. So this is just, I recommend you guys just to remember this one. When infinity goes to when x goes to minus infinity, and you realize there's a square root in your numerator, and your denominator can be negative as well, put a negative number in your numerator, like here. So here it's gonna be the same. So let's continue. Just this is gonna be 1 here. This is gonna be 1 here. This is gonna be 1. This is gonna be 3 here. My 6 is gonna be 3. So my limit, I don't have a space, minus infinity equal to minus 2 over x to the power of 3. Let's write this more beautifully. Plus 6 plus 1 over x to the power of 6 plus 1 divided by 1 plus 1 over x to the power of 3. So this is 0, this is 0, this is 0. And here I'm going to get minus square root of 6. So you see the difference when you have minus infinity and plus infinity. Just remind you, that doesn't mean if every time x goes to minus infinity that's going to give me a negative number, right? Sometimes my plus infinity and my minus infinity can give me the same number. Okay, you can never be too sure about that. For example, if I give you guys something like that, minus infinity with like x to the power of 2 plus x to the power of 3 divided by x plus 1, it's going to be the same thing as plus infinity, because this can give me negative and this can give me negative. Okay, so nothing changed. Okay, so this is that. All right, so let's take a new page. All right, so let's practice another one, right? So this time I'm gonna give you a whole new question. So limit x approach infinity for, let's take 7x to the power of 2. I'm going to plus 1 here, and here I'm going to take x, and let's say x minus 1. So what we're going to do is do the same as we have always have done, right? Let me think. Here I'm going to put to the power 2. So let's do this. As limit x approach infinity, let's divide x to the power of 2, since my x to the power of 2 is my highest power. Divide everything by x to the power of 2. So this is going to be 1, this is going to be 1 here, this is going to be 1, and this is going to stay the same, and 1 here. So my limit x approach infinity for 1 over x plus 7 plus x divided by 1 divided by x to the power of 2. And this is going to be 1 minus x divided by 1 divided by x to the power of 2. So let's plug in infinity. And this is going to be 0, 0, 0. And what's going to be left is 7. Now, how about x approach minus infinity? Well, let's try this. Since my numerator has no square root or absolute, I'm just gonna continue this. I'm just gonna write. I'm not. Nothing is gonna change from my positive infinity. So still the same thing. Nothing has changed since there's no square root. If you see a square root in your numerator or denominator, you know you have to divide it by negative number. All right, so let's do this. So it's gonna be the same. Nothing is gonna change. I'm just gonna do this quickly because we just done it previously. So we're still gonna get the same thing, right? Actually, let's do it again. Okay, still gonna be x divided by x to the power of 2 plus 7 x to the power of 2 divided by x to the power of 2 plus 1 x divided by x to the power of 2 plus x to the power of 2 divided by x to the power of 2 minus 1 x divided minus 1 divided by x to the power of 2. So I'm doing this quickly because we have just done this right here. Okay. So this is going to be 1 here in my numerator here, and this is going to cancel out, and my numerator is going to cancel out as well. So limit x approach infinity for 1 x to the power of 2 plus 7 plus x to the power of 2. Actually, made a mistake right here. This is x. 1 over x. So here is going to be 1 minus x minus 1 divided by x to the power of 2, 0, 0, 0 equal to 7. So nothing has changed because my denominator or my numerator always give me positive and negative number if depending on the infinity. Right? You always put a negative number next to the square root if your numerator is if you're depending on the situation, right? So if you have it, I'm just gonna write it quickly after I erase this because when I start learning calculus, this is what's confusing to me. So I'm just gonna write this. Anything that if my x is the power of 2 here, you're gonna have just write it quick. You're gonna have plus or minus 1. Same for this. Plus or minus 1. Okay? Doesn't matter where my square root is. If we have a similar case like this, or like this, you're gonna have a plus or minus 1. Right? So look for those kind of limits. If you want to put a negative number, if your infinity goes to negative. If your infinity doesn't go to infinity, doesn't go to negative, if your x doesn't go to negative infinity, don't do anything. You don't have to put a negative in front of the square root. Okay. All right. So now that that's done, we're gonna learn how to find asymptote. Right. So if you want to find a horizontal asymptote, so we're gonna talk about horizontal asymptote. Let's put my pen less. So horizontal asymptote, what I want to do is take my limit where my x approach infinity for my function, and I'm gonna get my horizontal asymptote. And I should do it again, this time with negative infinity for the same function, and I'm gonna get a second horizontal asymptote. This is like a second one, so this is the first. Right, first, second. And all right, so this is how you find your horizontal asymptote. And if you want to find your vertical asymptote, what you want to take is take limit x approach a. Let's take an example x minus a here, and let's take anything like f of x. Let's take x for example. You see, where my x minus a, I'm gonna get 0 if my let's say, actually let's try to erase this. Right, this is an example, right? So when my limit if my x minus a, we don't want it to equal to 0, so my x is gonna equal to a or possibly more. Okay, it's not limited to 1. So I will have like a lot of 1 or 2 or 3 numbers for my x for it to equal to 0. Okay. In this case, if x is equal to a, I'm gonna get 0 in my denominator, and when my x divided by 0 is gonna happens, it's gonna give me infinity, right? So anything over 0 is gonna give me infinity. So be careful for that. Right. So um, let's just write the condition right here. We want to find when limit for my limit x approach a for a function f of x to equal to plus or minus infinity. Right. So as I said, your a you should your goal when you're trying to find a vertical asymptote is to find what is your a, and is it equal to plus or minus infinity. So this is gonna be like your first one you want to find. You want to find this, and you want to find this limit as your second step. So there's two steps for vertical asymptote. So do not stop when you find your a. Okay, you should do the limit. So this is a horizontal and vertical asymptote. Now we're gonna put this in application. So what we're gonna do first is you guys a function. So I want to find my function. I want to find my asymptote for my function. So 2 plus 3x x to the power of 2 divided by 1 minus x. Alright, so let's start with the horizontal asymptote because we have just done x approach to infinity, right? So limit as x approach infinity for 1 minus x square root of 2 plus 3x to the power of 2. So we already have seen this type of question, this type of problem. Like this is not something new. What we just saw from what we have done so far. Okay, this is not something you should struggle right now. So try to do this question on your own and come back when you're done. If you don't know what to do, follow what I'm doing and try to see what you should do for all kind of questions that's coming, for your exam, for the homework, anything. Okay, so what I'm gonna do right here, I'm gonna divide by my highest power in my denominator. So all right, and let's think of yeah. All right. So if I look at my denominator, I see that it's x right here, right? X to the power of 1. So I'm going to divide everything by x to the power of 1. So I'm going to do that in my denominator first, right? Then I'm going to do that in my numerator. Divided by x. I see that x is approaching infinity and not plus infinity and not minus infinity, so I don't have to put a negative number in front of my square root, so everything is fine. So let's just plug in my x inside my square root. So if you guys have been listening, you should have known that my x is equal to x squared of x to the power of 2, right? So all right, it's the same thing here. So let's plug in my x to the power of 2. 2 divided by x to the power of 2 plus 3x to the power of 2 divided by x to the power of 2. This is going to equal to 1. And let's just cancel out there. So this is going to be 1 over x minus 1. And if I write down my limit, let's write this well. Just cross my line, not straight. Alright, so it's going to be 2 divided by x to the power of 2 plus 3, right? Divided by 1 over x minus 1. Let's plug in infinity. 2 over infinity give me 0. 1 over infinity give me 0. I'm left with square root of 3 divided by minus 1 give me a minus square root of 3. Right? So this is my first horizontal asymptote. Okay. Now we have to find my second horizontal asymptote if there is one. Right? It's not always the case, so be careful. Don't panic if you didn't find the second horizontal asymptote. Alright, so let's do this. So I have my square root right here. Oh, I made a mistake. This is minus infinity. So the same function, right? Now let's plug in. Now let's divide by the highest power from my denominator. Excuse me. So it's gonna be 1 divided by x minus x divided by x, except in my numerator I'm gonna put a negative number. Same function right here. Divided by x. So I just added a negative number because of my square root. It's mainly because of my square root, and my denominator can go to a negative number, right? So no matter what happened to my denominator, it's always going to a negative number. So I'll have to put a negative number in my denominator because my square root is positive. So alright, so we'll try to cancel out my x divided by x, gonna give me 1. And let's plug in. So here is gonna be x minus infinity. Jesus Christ, I write horribly. So here's gonna be 2 divided by x to the power of 2 plus 3 here. 3x to the power of 2 divided by x to the power of 2. Cancel out x to the power of 2. I'm gonna get 1 here, and 1 over x minus 1. If I plug in minus infinity, I'm gonna get here's gonna be 0. This is gonna be 0, and I'm gonna get minus square root of 3 divided by minus 1, giving me square root of 3. So we have found two horizontal asymptotes, right? So this is my first horizontal asymptote and my second horizontal asymptote. My first and my second. Okay. Note, I'm just gonna write, note how when my x approaches infinity, it's giving me a negative number, and x approach negative infinity is giving me a positive number. Don't panic out, and don't think that if my x goes to minus infinity, it's gonna give me a negative number. No, that's not always the case. Just don't be fooled by that kind of logic. Now we have found our horizontal asymptote. I want to find my vertical asymptote. So how do we find a vertical asymptote? So let's write our function right here. So our function is 2x. No, it's actually 2 plus 3x to the power of 2 divided by 1 minus x. So let's look at my denominator. 1 minus x equal to 0, and 1 equal to x. Okay, so if I plug in 1 in my function right here, this is my function, I'm gonna get infinity if x equal to 0, equal to 1, I mean. So that's something that we know. And if I plug in my 1 here and give me infinity, I know that I can try to do the limit with that. So let's do the limit. Okay, let's find out if my x approach 1, does this give me plus or minus infinity? So alright, so let's do this. So 2 plus 3x to the power of 2 divided by 1x divided by 1 minus x. Okay, let's do as we usually do with a limit. Can we simplify? No. Can we conjugate? No. Even if you try, it's going to lead us to nowhere, right? Can we factorize? No. Our only option is to plug in my my value. Okay. So if I plug in my value, it's gonna give me 2. It's gonna be 5 here. Um, in my numerator, and in my denominator, I'm gonna get 0, which leaves me plus or minus infinity. Um, Normally this is enough. Okay. I don't think a teacher is gonna ask you from the right or from the left. You don't have to go so that far. For me, this is enough to prove that you found your vertical asymptote. Okay, so you know that your one is your vertical asymptote, because when you do this, when you do x equals 1 for your function f of x, you get plus or minus infinity. So I have found my horizontal asymptote. This is my abbreviation, by the way. Horizontal for h, asymptote for a. And I got like minus square root of 3 and square root of 3. And my vertical asymptote, by the way, I'm going to erase that. I'm going to write it. The correct way to write it is horizontal asymptote x equal to this is f of x. F of x equal to minus square root of 3 and square root of 3. Vertical asymptote x equal to 1. So this is how you find your horizontal asymptote and your vertical asymptote. I hope you guys are following me, and I hope this was clear for you guys. If you have any question, comment down below. I'm always here for you guys. All right, have a great day and goodbye.